Welcome to Brain Vision.
This question, first of the question, here asking that block is moving 3 meters on the inclined plane, and after that block become rest. So in this part, we have to calculate the change in kinetic energy, and this is basically delta Ke equals Ke initial minus Ke final minus Ke initial. So Ke final is 0 and Ke initial is half into m, and m is 5 kg, so 5, and v square, v is 8 square. So this will, after calculation, become minus of 160 joule. This is the change in kinetic energy. And for the next part, we have to calculate the change in potential energy, which is nothing but the mg and the position changing in the edge. So for the B part, we have to use delta U, and delta U is UF minus UI, which is basically mg into h. So m is 5, g is 9.8, and h, where the vertical height is the distance moved into sine theta. So the distance is 3 meters, and sine theta means sine 30 degree, which is 1 by 2, and this will become 73.5 joule. This is the change in potential energy. In the third part, here we have to calculate the friction force on the block. So for the next part, we have to use from the given data that the we making block in the earth all system is isolated system, so there is no change in energy. So we are just applying delta Ke plus delta potential energy, plus there is also a non-conjunctive kinetic force, and their work done also will consider. So F is the fixed force here, D is the distance moved by the block on the inclined plane, which is 0. So delta Ke in this case we have already calculated this one, and this is basically 160, negative of 160, and delta U is equals 73.5 equals F into D. So D basically becomes 160 minus 73.5 upon D, and D is nothing but 3 meters. So after calculation, this will become 28.8 meters. For the next question, we have to calculate the coefficient of kinetic friction. For the coefficient of kinetic friction, we are using just in the component of the force along the normal is mg cos theta, and which is the normal case in this situation. So normal is mg cos theta. So the work done by the friction is 28.8 meters. So mg cos theta is the force into mu k into distance d equals 28.8. This is the work done by friction. So m is given here, which is 5. So directly mu k we can write it as mu k equals 28.8 upon mg. M is 5, g is 9.8, and cos theta. Cos theta means root 3 upon 2, because theta is 30 degree, and d is 3. So after calculation, we get the value of mu k, which is extremely in the range of 0.679. This is the value, and we get all this by step by step.